Now we discuss functions. Definition: if A and B are sets, then the Cartesian product of A and B it is denoted by A cross B. Is the set of all order pairs A comma B, where small a is element of set A and small b is element of set B. Okay. This Cartesian product is sometimes called as a relation. Okay, in some textbook, this is called as relation. A cross B, the set A cross B is also called as relation. Now next definition, it is definition of function. Let A and B be any two sets a function f from A into B is a subset of Cartesian product A cross B with the property that each A in A each small a in set A belongs to exactly one pair A comma B. Okay, so to each element of set capital A, there is exactly one image B. We can say that f is function from A into B if f maps an element A in set A to exactly one element in B. Notation. So instead of writing order pair A comma B belongs to F, we usually write B equal to F of A. So this is a notation. B is called image of A under F. A is called domain of function F. The range of F is the set of all B in set B such that B equal to F of A for some A in domain A. And this range is subset of B. Now one to one, now we discuss onto function, and then we discuss one to one function. Definition of onto function: if f is a function from A into B, we write f from A to B. This is a notation of function. If the range of f is all of B, then we say that f is onto function. Next definition is one-to-one function. Definition of one-to-one function: if f is function from A into B, then f is called one-to-one denoted 1-1. If f of A1 equal to f of A2 implies A1 equal to A2. Here A1, A2 are elements of capital A. Okay. So if images are same, then pre-images are also same. Thus, if f is 1 to 1 and b equal to f of a1, then b cannot be f of a2 for any a2 in the domain, so that a2 is not same as a1. Example, f defined from R to R means set of all real numbers, f of x equal to x square is not 1 to 1. Okay, because f of minus 1 is same as f of 1, answer is 1, but minus 1 is not same as 1. Okay, if we change the domain, then the same function may be 1 to 1. Okay, C whose domain is not real numbers, set of all real numbers, instead it is interval 0 infinity, open interval 0 infinity to R, and Z has same definition, g of x equal to x square. So this is 1 to 1. Okay, so if we sketch the graph of f, then it looks like this. This is f. Okay, so we can have same image for different points. Okay, say this is a1, this is a2, but f of a1 is same as f of a2. This point is f of a1, it is also f of a2. About z, z is not like this, z is only right hand side part. Okay, this is origin. If we consider z, then this is z. Okay, so here for each point in the range space there is exactly one pre-image. Okay, here we for f we have two pre-images. Okay, so g is 1 to 1, but f is not 1 to 1. The function which is 1 to 1 as well as on to is called um, bisective map. It is also called as 1 to 1 correspondence. If f is function from set A into B is 1 to 1 and onto, then f is called a one-to-one correspondence between A and B. If there is a one-to-one correspondence between should be between sets A and B, then A and B are called equivalent sets. Equivalent sets. Note that first thing, every set A is equivalent to itself. Okay, here map is identity map, f of x equal to x. Okay, identity map f of x equal to x from A to A. So this is one to one and on. Second, if A and B are equivalent, then B and A are equivalent. B and A are equivalent. Okay, so if f is one to one onto map from A to B, then we can always find inverse mapping of f. Okay, so if f of A equal to B, then we can have inverse map as g from B to A, and we define g of B equal to A. So g is also one to one and 1, and this gives B and A are equivalent. Third thing, so this property is called as symmetry. If A and B are equivalent, and C and D are equivalent, then A and C are equivalent. Sorry, I should write, if A and B are equivalent and B and C are equivalent, so that should be B and C are equivalent, then A and C are also equivalent. Okay, so this property is called as transitivity. Okay, so this uses composition of functions. Okay, So these are basic things about functions.